regarding the moving coil galvanometer, we shall require to know more about it. The equation given is the equation of galvanometer. This equation eta represents the deflection in galvanometer. Eta, the deflection in galvanometer. Equation says this deflection is a function of these parameters. The parameters are N stands for number of turns on the coil. A, area of cross section of the coil. B stands for the applied magnetic field on the coil. C, the spring constant. And I stands for intensity of current flowing through the galvanometer or the coil. In this equation, this is a function of these parameters. Once the galvanometer is fabricated, we get the finished product, that is device. In the finished product, these parameters after the product is finished, these parameters N, A, B, C will remain constant for that galvanometer until its usage. Look at this, all these parameters are constant, and mathematical form of this is also a constant. Let us write this entire function of mathematics as constant, because all of them are constant for that galvanometer. Now the equation is simplified. Eta is equal to K into I, constant. Eta is directly proportional to the current flowing through the galvanometer, where that K is called as galvanometer constant. K stands for galvanometer constant. Now this equation, because we are using this units now, the angle of deflection, the unit is radians in SI. Can use angle, but radians is a unit in SI. And I, the ampere in SI. K is a constant. Using this equation, it is easier to define the galvanometer constant. Look at that equation. When you put I equals 1, unit value of current, that is 1 ampere, that is eta equals K. What is K? K is eta. Now you can define K is radians. That is a deflection in the galvanometer in radians. Per unit current, per ampere, K is the radians or the deflection in the galvanometer per ampere. Is the definition for constant. The constant is galvanometer constant. And this galvanometer has two properties of sensitivity. One is the current sensitivity and the other is voltage sensitivity. The definition for current sensitivity, recall that phi divided by I, the ratio is called as current sensitivity. What is the diffraction? By this current. That is the current sensitivity of the device. We can symbolize as high S current sensitivity. You can write the expression for this by using this equation, but rewrite this as like this. Taking I onto the left hand side, it becomes right hand side, only we have these values. Now IS equals, what is the current sensitivity of the galvanometer? N into A into B divided by C. The sensitivity depends on these and inversely to this value. Similarly, we can define the voltage sensitivity. Voltage sensitivity is, this ratio is called as voltage sensitivity. Pi divided by V, this ratio, that is a deflection by this voltage. The ratio is called voltage sensitivity of the galvanometer. Let us symbolize as Vs. V stands for voltage, S stands for sensitivity, voltage sensitivity. So we know that V is equal to IR, the Ohm's law, I into R. Already we know what is this ratio, pi by I. Substitute for this. R is denominator. So this is voltage sensitivity of the galvanometer. We have two equations. Let us compare these equations. These two equations. So we get this equation. Vs is equal to Is divided by R. Vs equals Is divided by R. Comparing these equations. This equation gives the relationship between the two sensitivities, and R stands for resistance of the galvanometer. Resistance of the entire wire wound over the coil. That is called resistance of the galvanometer. This equation is useful for the calculation of resistance of the galvanometer if we know the values of Is and Vs, that is current sensitivity and voltage sensitivity. So there is one problem, one such problem. Given Is equals, current sensitivity is equal to 5 divisions per milliampere per unit of current. The unit of current is milliamps. So you can milliamps or ampere. And you are using divisions on the scale. The scale is angular scale like this. So now it is not in radians. We can represent the radians in the form of divisions, number of divisions, because there is angular shape. These divisions on the angular scale is same as the radians, almost directly proportional to the radians. So it is represented as 5 divisions per milliampere current sensitivity. Similarly, we have voltage sensitivity 12 divisions per volt. That is 12 divisions per volt per unit of volt. And asked her to calculate resistance of the galvanometer. What is the resistance of the galvanometer R? Use this equation. Before this, let us write all of them in SI unit. It is not in SI. So we have to convert milliamps into amps. So Is equals given like this. 5 divisions divided by milliamp. What is milli? 10 to the power of minus 3. It is in the denominator. It is per milliamp. When I simplify, it goes to denominator. 5 into 10 to the power of 3 divisions per ampere. Now the current sensitivity is given in per milliampere. Now it is in amperes. If this is the angle of deviation, that is the deflection per milliamp, and this is the deflection per amp. It is in SI, write it as it is in SI. Write the equation. And what is R? Rewriting this equation, Is divided by Vs. Substitute for these values. Vs is this. Simplify, we get this 250 ohm. What is our resistance of the galvanometer is 250 ohm. So knowing the sensitivities, we can able to calculate resistance of the galvanometer. This is one such problem. And one more we need to understand here about the sensitivity, this equation. As you know, this equation is of course the function of these parameters. In this equation, let us maintain A, B, C constant and take n as a variable. Let us take it as n variable, for example. So we see that we are taking only n as variable, remaining as constant. Look at the equation. Highest, it is in your numerator, directly proportional to n. And you know what is n? Number of turns in the coil. These number of turns increases as the length of the wire increases. Then L is also directly proportional to L, length of the wire we are using for winding of the coil. And one more point, this length is directly proportional to resistance. As you know, resistance of wire is directly depends on the length. So if this proportional to n, this is proportional to L as well and as well as R, directly proportional to all these factors. This is looking at directly or indirectly like this. So on this concept, let us work out problems. The problem is given. If n equals 2n, what does it mean? In the given galvanometer, let us change the number of turns. N is the number of turns. 2n means double the number of turns. Sometimes we can triple the number of turns. Sometimes we can increase the number of turns by 4. Let us increase the number of turns by 2. That is double the number of turns. If the number of turns are double, what would be the value of Is and Vs? Will it increase or decrease or will remain same? That we need to understand. So we have these equations. This equation for Is, equation for Vs. Let us verify this. Given data, if n equals 2n, I told you n equals 2n, this n proportional to L. If n is 2n, L becomes 2L because they are directly proportional. If L is 2L, R becomes 2R, directly proportional to R. Accordingly, we can write this. Given data, then L equals 2L, R equals 2L. Then find out what is Is and Vs. Is equals this equation. Let us change n into 2n, double. Change that n into n and see what is the effect on Is. This is the effect. And look at this. This is after changing the number of turns, Is. On comparing these equations, Is dash is equal to 2 Is. This is after the effect, I dash. Look at this, Is. That is, Is is double when the number of turns double. What does it mean? Current sensitivity of the galvanometer doubles. If number of turns in the coil doubles, current sensitivity increases as the number of turns increases. And let us verify the voltage sensitivity. Write the equation of voltage sensitivity NAB divided by CR. Substitute for the change. What is the change? If n equals to n, overall R equals to R. We have both n and R. change n into 2n. If you change n into 2n, r also changes to 2r because it is the one I am given accordingly the proportionality ratio. And simplify 2 to get cancelled, we get back the same. What is V dash is the effect after this change. What is Vs? On comparing these equations, this is CR. CR remains because only 2 cancels. CR. Same equation. When the number of turns increases, but voltage sensitivity remains same. You need to know this, very important. These questions will come in the aptitude type as well. If the number of turns increase or decrease, if the number of turns increases, current sensitivity increases, but voltage sensitivity remains same. If the number of turns decreases, current sensitivity decreases, but voltage sensitivity remains same. There is an effect only on the current sensitivity, no effect on the voltage sensitivity. If you change the number of turns, increase or decrease. That is what we understood from this concept. Next is about the galvanometer. Let us see the galvanometer directly, the meter, the scale and the needle. What is the needle? Diesel. Needle I put inside. This magnetism is always fixed perpendicular to the coil. These two dots are the terminals of the galvanometer, to which what is that? We give the connection to the circuit. Two terminals. The scale is always in angular shape because deviation is angular deviation. It is 0. Look at the scale. The scale is divided into 25 divisions on the left hand side as well as right hand side. 25 divisions, equal divisions. The needle can deviate either to right or left. Depends on the direction of the current flowing through the galvanometer. So suppose it is deflecting towards this side. We can record this, what is the value? This equal divisions, that is 0 to 5, small divisions, equal divisions, 5 divisions, 5 more divisions, totally becomes 10, 15 divisions, 20 divisions, 25. Only this is maximum divisions, 25 divisions, equal divisions. And the scale is mentioned. Usually after this make, the scale is mentioned. The scale on this galvanometer is 20 microampere per division. Look at that, microampere, very small current, highly sensitive galvanometer. Sometimes the scale is mentioned as milliamp, that sensitivity is little lesser. Microamp is a sensitive galvanometer. It can record even microamps. What is the scale? 20 microamp per division. What does it mean? If the needle deviates and it is directed to one division, the current flowing through the galvanometer is 20 microamp. If the needle is showing two divisions, current flowing through the galvanometer is 40 microamp. Like that we can calculate. If the needle is directed towards 5 into 20, 100 microamps current is flowing through the galvanometer. And what is the maximum current it can record till deflection? Here it can deflect, maximum deflection is this. When it is completely towards 25, what would be the current? It is the maximum current it can record, not more than that. What is that maximum current for 25 divisions? 20 into 25. 20 into 25, it is 500. It is microamps. Micro means 24 of minus 6. So write them 20 into 25. It is in microamp. Substitute for micro. Calculate in amperes. 10 to the power of minus 6. 5 into 10 to the power of minus 4 amperes. Look at this. It is in amperes, and we can convert it to milliamperes as well as. It is same as 0.5 milliamps. What is this current, amount of current? This galvanometer can record a maximum of 0.5 milliamp. Beyond that, it cannot record. There is no provision. Only that sensitivity. What is the current? This current is symbolized as Ig. Ig, what is Ig? This symbol is used in all the books. What is Ig? Current for the maximum deflection in the galvanometer. Full deflection. Maximum deflection current. That is called as maximum deflection current. Higher limit, maximum limit is this. It can record the current below this, up to this, not beyond that. That is the sensitivity. This galvanometer can be used as a meter. In case of this is, if you want to measure this current, it becomes a meter. We can use this galvanometer to measure voltage or calculate voltage. What is the voltage measure? It equals this because current we are recording. We convert this current into voltage using what is the saying here? Ohm's law. V is equal to IR. Here I is the current. For maximum current, let us calculate. We get maximum voltage. So this is the maximum current deviation. What is the maximum voltage can indicate? You have to calculate using the equation. That is Ig equals, this is the value in amperes. And what is G is resistance. What resistance? Resistance of the galvanometer. Resistance of the wire. It is wound over the galvanometer. It is depends on voltage range, depends on the resistance of the galvanometer. Let us assume the resistance of the galvanometer is 100 ohm. It may be 50, 100, 200. Depends on the wire we are using. On the length it is uses. If G equals 100 ohm, what is the voltage? Calculate this. Current into voltage, that gives volt in SI units. 5 into 10 to the power of minus 2. What is that value? This galvanometer record a maximum of this value 5 into 10 to the power of minus 4. Suppose in microvolt like that. Maximum this line, if the deflection is here and voltage is this, is the voltage it records. Not beyond that, within that only. So for every deviation you can calculate entire thing divided by 25. It gives for each division, voltage for each division. From this, what is that? And the galvanometer scale and what is the divisions we have calculated for this particular galvanometer. It is different for different galvanometers. Depends on the make. For this galvanometer, Ig, what is Ig? Current for the maximum deflection. That is 0.5 milliamp or in SI this one. And voltage, maximum voltage you can record. This is the range. So range of current, this meter galvanometer record is from 0 to 0.5 milliohm. From 0 to 0.5 milliamperes. And the range of voltage it measure from 0 volt to 5 into 10 to the power of minus 2 volt. That is our maximum limit. That is a sensitive galvanometer. Practically, we have a number of circuits. In most of the circuits I am talking about. The circuits whose current is quite larger than this. Quite what is that? Very much more than this current in the circuit. And the voltage that is practically and in reality the circuits what is using these practical purpose or domestic the measurement of the voltage. The voltage in that circuit usually it is very much more than this. It is in micro values. They are in voltages 5 volt, 50 volt like that. And the amperes not in micro amperes or milliamperes. The circuits can have 1 amperes, 5 amperes, 20 amperes, 30 amperes. That is the current intensity in practical purpose. How do you measure that current strength and voltage? Using galvanometer. If you connect this galvanometer directly to the circuit having very high intense current or very high voltage, what will happen? If you connect this galvanometer, which can have a range like this, current and voltage, if you connect this galvanometer into that circuit having high voltage, high current, the galvanometer device experiences electrical overload. Electrical overload. The system or device experiences electrical overload. Cannot withstand. Very sensitive. The device cannot withstand that overload. It breaks down. It breaks down. It damaged. It is getting damaged. What damage? Irreparable damage. If you connect directly to a circuit of that source of current, device, what is that? Damaged. The damage is irreparable damage. What does it mean? After that, there is no way you have to throw it as a waste. Completely it is damaged. No further use. Very sensitive device. Then, if that is the case, how can we use this galvanometer as a hub meter and voltmeter in such cases? If that is the case, we are applying one technique, very important. That technique, what is the technique? To prevent that current, what is that? Current element, that is this amount of current or this amount of voltage. Some design or device, what is that? A technique to prevent the flow of what is that? Electrical limit and electrical voltage. Not that very high electrical. Only allow that device or what is that? The technique. What the technique here? The technique is a technique of device in a circuit. A technique of device in a circuit which allow the current passing through the galvanometer within this limit, within this maximum limit. The technique what you are applying, the technique of device in the circuit, I will tell you later. The technique of device in the circuit so that their design will allow only the current, what current? Current flowing through the galvanometer is within this limit, not beyond this limit. That is 0.5 millimeter for this galvanometer. And similarly, the device or what is the technique you are applying in the circuit, in case of voltmeter, while measuring this voltmeter, will the design will allow only the voltage across the galvanometer. A voltage across the galvanometer is within this limit, within this maximum limit. See that the device or design in the circuit will not go beyond this limit of current flow, not go beyond this voltage across the galvanometer. The design is very important. Let us see what is the design and technique in the next session. It is, you can use as ammeter, as voltmeter to measure even 20 amps, 30 amps, even the voltage 100 volt, 250 volt using the technique or designing the circuit without damaging this galvanometer. That is understand in detail in the next class, next session.